In this lecture, we do 5 number summary, box plot, variance, and standard deviation. We do these topics. This is lecture 7 of our probability and statistics course. So what is a 5 number summary? The 5 number summary of a data set consists of the following 5 numbers: the minimum number, the first quartile, second quartile, which is the median, the third quartile, and the highest number. So from a data, if we put these numbers, these 5 numbers together, that is called a summary of the data, and that is the 5 number summary of the data. So these 5 numbers are like important numbers in a data, important numbers from the data. So these numbers represent a 5 number summary. Find the 5 number summary of the data, and this is the data. Now we find 5 number summary, and see 5 number summary has the minimum and the first quartile and the second quartile, third quartile, and highest number. So we need to put the data in order, in ascending order. So we need to arrange the data. Okay, so we first put in order. We first put the data in order. Okay, increasing order, ascending order. So let's say 67, 68, 68, 69, another 69, and then another 69, and then we have 4 70s, 70, 70, 70, 70, 671, which is 1, 2, 3, 4, 5, 6, 71. So 71, 71, 71, 71, 71, 71, right? 671, and then 272s, 72, 72, and then 73 and 74, and 73 and 74. Okay, so this is we put the data in order. Okay, and why we need to put the data in order? Because to find the median, the data has to be ordered data, and also these quartiles, we need the data be in order. So we put the data in order. Then this is the minimum number, right? So this is the maximum number. Now let's find the median. So how many numbers in here? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we have 20 datas, 20 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. 10 and 11. These two numbers are in the middle, right? So these two numbers. So the median is 70 plus 71 divided 2, which is let's see, 70 plus 71 divided by 2, this is 70.5. okay, so this is the median. Now this divides into 2 halves. The median number divides into 2 halves. Take the first half, and find the median again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we get 1, 2, 3, 4, 5, 5 and 6. These numbers are in the middle. So from here you get Q1 is 69, because 69 plus 69 divided 2 is 69. And from the second half, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 plus 1. 11 divided 2 is 5.5, right? So 1, 2, 3, 4, 5 and 5. So these two numbers in the middle. So from there you get Q3 equals to 71. Okay, so the 5 number summary is, let's see, the 5 number summary equals to, put these numbers all together, 67 comma 69 comma 70.5 comma 71 and 74. This is the 5 number summary of this data. Okay, so for 5 number summary, we find the minimum number and the quartile, the first quartile, and then the median and the third quartile, and the maximum number. Okay, so when you put the 5 number summary as an answer, you put these numbers in order. Okay, so first you put the minimum number, and then you put the first quartile, and then the median, which is the second quartile, and then the third quartile, and then the maximum number. So don't put like 67 and then 71 and 69. You need to put these numbers in order because they have to be in increasing order. Like, so we write the minimum and then the Q1 and then the median and then the Q3 and then the maximum number. Okay, so don't mess these up. Like, don't put it, you need to put this also in the order. Okay, in the increasing order. Okay, so that's how we find the first number summary. The first number, the 5 number summary. The 5 number summary has to have these 5 numbers. So we find these 5 numbers and put them together. Alright, now question 2 is obtain 5 number summary for the data. And this data is already sorted. So it is already the in increasing order. So we choose the minimum number, which is 40. And the maximum number is 95. And the median is how many numbers in here? So 5, 10, 15 numbers, right? So 15 numbers, then you have 8th number in the middle. So 1, 2, 3, 4, 5, 6, 7, 8. So this number is in the middle, which is the median. Okay. And then in the first half, we get 1, 2, 3, 4, 5, 6, 7 numbers because we don't take the median now. So we don't take the median, and the rest of the number, we take the rest of the number for the first half, and then you choose the middle number. Okay, so this is in the middle, 54, right? So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 1, 2, 3, 4, yes. So this is the middle number. And from the second half, we don't take the median again. So starting at 73, count these numbers and take the middle number. 73, 80, 85, 75, you this. So 1, 2, 3, 4, 5, 6, 7 number again. So 1, 2, 3, 4. This fourth number is the is in the middle, right? So the minimum is 40 and the median is then we found the median, which is Q2. Q2 is 69, right? And then the first quartile, Q1 is 54 and Q3 is 87 and the maximum number is 95, right? So the 5 number summary has to be first the minimum number 40 comma and then the Q1, right? So then Q1 is 54 and then 69 Q2 and then 87 and 95. Okay, so this is the 5 number summary for this data. Okay, now the box plot. What is a box plot? Box plot is a diagram which highlights the 5-number summary of the data. Okay, so the box plot looked like this, and it has a line in the middle, and there is a box in the middle, right? And this box has 3 points, 3 important points: the starting point of the box, and there is a line in between, in the middle somewhere. It is not exactly in the middle, it may be in the middle exactly, or maybe some other places. Okay, so that number is the median actually. And then the ending point of the box, which is Q3. Okay, so this line here is called the whisker, because this plot is also called box and whisker plot. So there is a whisker, and the starting point of the whisker is the minimum entry. We put the minimum number. The whisker ends at maximum number. So there is a line, a whisker, extending from minimum to the maximum number. And there is a box in the middle, and the box we set up like this. So the first point of the box is the Q1, the first quartile, and the middle number, somewhere the other line, is the median, and the ending point of the box is Q3. So this is the box plot. Okay, so this looks like, the box plot looks like this. And the thing is, the thing is, we did already that these numbers, Q1, Q2, Q3, these numbers are the quartiles, right? So they divide the whole data into 25% of each. So we get 25% of the data in between minimum number and the Q1. So this part of the data is 25%. This part represents 25% of the data. Okay, so this is 25% of the data. Okay, if there are 100 points, if there are 100 numbers, then the 25% of the data represent into this, represented by this part. And again, Q1 and Q2, there is 25% data in between Q1 and Q2. So this part is 25%. Okay, 25% of the data. And again, between the Q2 and Q3, we get 25% of the data. 25% of data. And from Q3 to maximum number, we get 25% of the data. So each part of the box plot represents 25% of the data. Okay, so this may, sometimes we may need to use this thing, like we have 25% of the data, like we have some questions like this where we need to know that there is a 25% of the data lies between the minimum entry and Q1, and between Q1 and Q2. So each part of the box plot, this part and this part and this part and this part, these are 25% of the data. Okay, now draw a box plot that represents the data set which has the following 5-number summary. So this is the 5-number summary, and let's draw a box plot. Okay, so let's draw a box plot. So how does the box plot look like? See, now we have the minimum number is 11 and the maximum number is 35, right? So let's draw a line. Okay, let's draw a number line actually. Let's draw a number line, and then we can start at 10 because our minimum number is 11, right? So 10, then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and maximum number is 35, right? So 31, 32, 33, 34, 35. Okay, so we can, because this is the number line, so we can draw 36, 37, 38, 39, 40. So we can draw some extra numbers. Okay, now let's draw the box plot. So where do the whisker start? The whisker start at 11 and ends at 35. So here is 11. So we start at here. Okay, and we end at here. Okay, so this is the whisker. Now the box has to start at Q1 and end at Q3. So Q1 is 23, 20, 21, 22, 23. So here is the box started, and Q3 is 30. So here is the box ends. Okay, so this is the whisker, the minimum number, this is the maximum number, and this number here is Q1, where the box, this rectangular box that starts, and here the box ends, right? Now there has to be a median number in between the box, right? So somewhere, so what is the median? Median is Q2, which is 25. So 25 is here. So just above that 25 numbers, draw a line. So that is the median. Okay, so this is the minimum number, which is 11, and this number here is 23, and then the median is 25, and then the Q3 is 30, and then 35. Okay, so this is how we draw the box plot for any given data like this. Okay, now see, as I discussed before here, that 25% of the data, 25% of the data. So there are 25% of the data numbers between 11 and 23. So in this part, there is 25% of the data. And between 23 and 25, there are 25% of the data. So this part looks like smaller, right? And this looks like bigger. That doesn't matter. This means what? You have more numbers between 23 and 25. So the data is like you have 11 and then 13, 15, 17, 19, and then 23, 23, 24, 24, 23, 25. So you get exact number of data that you have in between 11 and 23 and between 23 and 25. So you have the numbers, you have the equal number of data between 11 and 23 and 23 and 25. So 25% here, 25% here, 25% here, and 25% there. Okay, so if there are five numbers, if there are five data in this group, then there are five numbers in this group. So if there are five numbers between 11 and 23, then there are five numbers between 23 and 25, and there are five numbers between 25 and 30, and there are five numbers from 30 to 35. Okay, so that's how we get 25% of the data in each group. So even though it looks like not exactly in the middle, it doesn't need to be exactly in the middle, because we may have the data set like we get more numbers between 23 and 25, and then there are less numbers between and after 25 to in between 25 and 30. So but 23 and 25 there are more numbers, and then 25 to 30 there are equal number of data. Okay, so that's what I was trying to say, that the box plot may look like it doesn't have exact in the middle. It doesn't have to be. We are just counting the percentage of the data. Okay, so this is the percentage of the data, 25% from each part. Okay, now this question is, draw a box plot for the given data. So we have a data, and this data is not arranged, so we have to first put them in order. We arrange the data first, so let's do that. First we put the data in order, increasing order. Okay, because we need 5-number summary to draw the box plot, right? So we had 5-number summary for this question, but this question we don't have 5-number summary. So we need to find out the 5-number summary, and then we draw the box plot. Okay, so we first put the numbers in order. 6, 7, 8, 9, 10, 14, 15, 16, another 16, 20, 23, 33, 50, 58. Okay, so this is the arranged data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so we got 15 numbers. Now this is the minimum number. This is the maximum number. And which number is in the middle? So if it is 15, if there are 15 numbers, remember how we did the median? When we did median, we did 15, like we did this way, right? So we did n plus 1 divide 2. So if there are 15, then 15 plus 1 divide 2, which is 16 divide 2, which is 8th. This is the median, right? So let's count 1, 2, 3, 4, 5, 6, 7, 8th. This is the median. This is the minimum number. This is the maximum number. This is the median. And the median divides into 2 halves. So let's take the first half. Without median, take the other numbers and take the first half and find the median again. So 1, 2, 3, 4, 5, 6, 7. 7 plus 1 is 8. Divide 2 is 4. So 1, 2, 3, 4. So this number is Q1, the first quartile. And 1, 2, 3, 4. This number is the third quartile, Q3. So now we got the 5-number summary. Now we draw the box plot, right? So let's draw the box plot. We draw a number line. So the minimum is 6, so we can start at 5, and the maximum is 58, so we can end at 60. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 1, 2, 3, 4, 5, 55, and 1, 2, 3, 4, 5, 60. Okay, so we got the number line. Now we need to draw the box plot. So the minimum is 6, so we can start the whisker at 6. This is the minimum number, and then end at 55, 58, 55, 56, 57, 50, 58 is here. Okay, so the whisker goes from 6 to 58. Now the box is starts at Q1, which is 9. 9 is here, so the box starts here. Okay, and ends at 23, 20, 21, 22, 20, 21, 20, 23. So here the box this. Okay, and then the median is 16, 15 and 16. So here is the median. Okay, so here is the minimum number. This is the minimum number. This is the minimum number, and here is Q1. This number is Q1. This number is the median, and this number is Q3, and this number is maximum number. Okay, so this is the box plot for this data. Okay, see here we got so small place, right? But if you look at the data, you get 25% of the data in between minimum and Q1. How you get that? Because this is the minimum and Q1. So how many numbers are here? So 1, 2, 3, right? So 3 numbers. And again, if you don't count Q1 and median, there are another 25% of the data between Q1 and median. See, 1, 2, 3. See, you get 3 numbers in between each of these group, right? In these groups, so you get equal percentage of data being spread in the data set. So you get 25%, 25%, 25% and 25%. This looks much bigger space, but we have just 3 numbers in between Q3 and maximum number. So this line doesn't matter. 25% in between each of these numbers. Okay, we get 25% of the data. Okay, now that's how we draw the box plot. Now here is a question that says that study the box plot is given, answer these questions. A box plot is given 50, 59, 75, 91 and 100. And it says the box plot for the test score of 32 student. 32 student is the total number of student. Total number of student in a class is 32. And these are the score that the students get. Okay, so nobody got below 50 and nobody got above 100. So the score was between 50 and 100, and there are 32 students in the class, in a classroom. Use this box plot to answer the following questions. Okay, how many students made above 75? Okay, now this is the it says how many students. So it says the number of students, how many made above 75. See, 75 is here, right? So above 75 is 25% in 75 and 91 and 25% in this. So each group is 25%. Okay, so this is 25%, this is 25%, this is 25% and this is 25%. So above 75 is 25% and 25%, 50% above 75, right? So 50% of 32 students, because we need to find the number of students. So 50% of 32 student, which is 0.50 times 32. 0.50 times 32 is 16. So 16 students made above 75. Okay, so that's why I was saying that, see, these percentages, these are important to know. These percentages, this what I said here, 25%, 25%, because that is important thing to know, that we have 25% from each of these groups. So we have each of these group. Now this question says above 75, so we got 50% above 75. So 50% of 32 is 16. Okay, now the second question, how many students made below 91? Below 91 is here, so below 91 is we get 25%, 25%, 25%. So we get 75% is below 91. So 75% of this many students, because it says how many students. 75% of 32, and this is 0.75 multiply to 32, and this is 24. So 24, these many students made below 91. How many students made below 59? 59 is here. Below 59 is 25%. Okay, so don't choose 50 answer, because this is the score, not the number of students. We need a number of students. Okay, so what percent of students lie in between 50 and 59? 25% lies in 50 and 59. So 25% of 32 students, right? So below 59 is 25%. 25% of 32. 25% of 32 is 0.25 multiply 32 is 8. So 8 students made below 59. How many students made between 59 and 91? Now 59 is here, 91 is here, and it says how many students. So first of all, what percentage of students between 59 and 91? This is 25% and this is 25%. So between 59 and 91, we have 50%. So 50%, because 25 and 25, 50, right? So 50% of 32, and 50% of 32 is 16. So we get 16 students made between 59 and 91. How many students made between 59 and 75? 59 and 75, 25%. So 25% is 8, right? Now 0.25 times 32, which is 8. And here, what percentage of students? Now this question asks for percentage. What percentage of students made more than 59? More than 59 is more than 59. So 25, 25, 25, 75%. So 75% student made more than 95, more than 59. Okay, so this is how we look at the box plot and answer these questions. Sometimes we need a number of students, so we multiply the percentage, because we know that this part is 25% and 25%, 25% and 25%. So if it says between 59 and 75, then that is 25%. If it says 75 and 91, that is 25%, and this is 25%. Between 50 and 59, 25%. Okay, so based on that information, based on that knowledge, we find out the total number of students between any two numbers. Okay, so this is the first page. Now let's go to the next page. Okay, in this page we have the standard deviation. We find the standard deviation. We did a 5-number summary box plot, and now we do variance and standard deviation in this part of the lecture. Let me put this page. Okay. Now, what is a standard deviation? Standard deviation measures the variation of the data set about the mean. How far are the data set, are the data from the mean? That measurement is standard deviation. The standard deviation is always greater than or equals to 0. The standard deviation is always greater than or equals to 0. When the standard deviation is 0, the data set has no variation and all entries have the same value. As the entries get further from the mean, that is more spread out, the value of the standard deviation increases. So this is what you have to know about the standard deviation. It says how much is the data spread out. That measurement is standard deviation. Let me give you one small example. What is a standard deviation? See, you have a data A, which is this data, okay, and you have another data here, okay. So let's see, this is this has 25 dots, for example, right? So this is 25, there are 25 dots, means 25 data, and let's say this has 25 dots, so 25 data. So the number of data is same, 25 dots here, 25 dots there. Now in this data, all the numbers are close to each other, and here the numbers are a little farther from each other. This data is more compact and this data is more spread out, okay. So let's say this is the mean of this data. Then if you measure the distance from the mean of each data, you will see that the number that distance from the mean to the data are less compared to this one. If you have the mean here, then this distance, for example, is bigger than this distance, right? So this data is more spread out, and the distance from the mean to the data values are bigger. So this data has more standard deviation, bigger standard deviation than this data. This data has a smaller standard deviation because this data is more compact and this data is more spread out. So the standard deviation is a measurement. This is a number which gives us an idea that how far the data are spread out. If the data is more spread or the data is compact, that estimate we can get from standard deviation. Now look at these two examples. This is corporation A, corporation B, salary, starting salary, and so we have in this data the salary starts at like 35,000 and ends at 50,000, 52 or something. So this has less variation, it is more compact, but this has more spread, okay. The starting salary is 20,000 and the starting salary starts from 25,000 to 60,000. So this data, corporation B, has more standard deviation. The standard deviation says how far the data values are spread out from the mean. Corporation A has a lower variance and lower standard deviation because the data are less spread out here, okay. And this is less spread out, this is more spread out. Corporation B has higher variance and higher standard deviation compared to the corporation A, okay. So simply we can understand that if the data are more spread out, then the standard deviation is greater, bigger standard deviation. Now, we have formula to calculate the standard deviation. And when we talk about the variance and standard deviation, there are two types of standard deviation and two types of variance. So one is called population variance and one is sample variance. There are two terms of variance and standard deviation. If you find the population variance, this is the formula. If you find sample variance, this is the formula. Population variance is denoted by sigma square nu or sigma sum, this notation square, and sample variance is s square. Okay, so standard deviation is the square root of variance. So sigma equals to square root of this formula. So this is the formula for standard deviation of population standard deviation, and this is the formula for sample standard deviation. The difference in these two is you need to divide by some number. If you find the population variance, you need to divide by the total number of items, total number of data. And if you find the sample variance, you divide by n minus 1, one less from the total number of data. Okay, that's what we have the rule, like we find in this way. Okay, so you find the standard deviation, population standard deviation, divide by n. So n is number of data entry, and here this mu is the mean, population mean, and x bar is the sample mean, and then you divide by n minus 1. This is for sample standard deviation. Okay, so using this formula, and getting the standard deviation, that is our topic in this page. Okay, now there are some steps to follow to get to this place, to get to this formula. To get into this formula, we need to do something, right? So we need to first find out the x bar, and then we subtract the x bar from the x, then you square it, and then you sum it, and then you divide by n minus 1, right? So these steps we do to find out these things, and then we find the square root, okay, to find the standard deviation. So to find the standard deviation, we follow these steps. Find the mean, sample mean. If you find the sample variance and sample standard deviation, find the sample mean. Okay, that means just find the mean. Okay, so you have most of the questions that we do here are the sample. Like we have a data like this data, this is a sample. Okay, so if it says this is a population and find population mean or find population standard deviation, then we use the n and this formula, sigma square and sigma formula. Okay, but otherwise we understand that these are the sample, and so we find the sample standard deviation. So unless it says a population, right, so we do all samples, sample mean and sample standard deviations. So we find the sample mean, subtract the mean from each data entry, find the square of each difference, then find the sum of the squares, then divide by n minus 1. After doing these steps, you will get sample variance, because when you do these steps, you will get this thing, which is the sample variance formula, this formula. Then to find the square root, then you find square root to find the standard deviation. So then you find the square root. So we have 6 steps to do. And to find the population variance, follow the same method. You find the population mean, and then subtract the mean from each data entry, then square the difference, then find the sum of the squares, then divide by the total number of entry, And then after doing this, you will get the population variance, which is this, and then find the square root of the to find the standard deviation. Okay, so let's do these two questions and these three questions. So we have three questions here to find the standard deviation, I guess. Find the sample standard deviation for the given set of ideal numbers of men and women. Okay, so we have these numbers. Okay, so first is we find the mean x bar. Okay, so this is the mean x bar equals to you add these numbers and divide by 1 2 3 4 5 6 7, divide by 7, so 4 4 8 12 14, 14 divide 7 is 2. Okay, so mean is 2. Now subtract the mean. Okay, so let's subtract the mean from each of these numbers. 0 minus 2, subtract the mean. 0 minus 2, 0 minus 2, 2 minus 2, 4 minus 2, 4 minus 2, 4 minus 2. So what I did, I subtracted the mean from each data entry. Okay, find the mean and then subtract the mean from each data entry. Right? So I subtract 0 minus 2, 0 minus 2, 0 minus 2, 2 minus 2, 4 minus 2, 4 minus 2, 4 minus 2. So I get this. Now this says find the square of each difference. So now what I'm going to do is I'm going to square these things. Square. Okay, so I square these differences and then find the sum of square. Now you add these numbers. Okay, so I add these numbers. I did all these steps in the same place because I didn't have much space here. And also we can do all these steps in a single step here. So like this, you can do 0 minus 2 square plus 0 minus 2 square, like that. Okay, now then it says find the sum, right? Now you divide by n minus 1. So this whole thing divided by n minus 1. N equals to 1, 2, 3, 4, 5, 6, 7. So n minus 1 is 6. So divide by 6. Okay, divide by 6 and then you find the square then you find the square root of the whole thing. Square root of this whole thing. Okay, so this is, now you calculate this and that this answer is the standard deviation. So let's see what I get. Let's do here. 0 minus 2 is negative 2 square is 4 plus 0 minus 2 is negative 2. Negative 2 square is positive 4 plus 4 plus 0 plus 4 minus 2 is 2. 2 square is 4 plus this is 4 and this is 4. Divide 6 square root. Okay, so 1 2 3 4 5 6 is 24. Divide 6 and this is square root of 4 and 2. So the standard deviation is 2. Okay, so the standard deviation of this data is 2. Okay, you see that? Okay, now this is the standard deviation. Now this one, let's see. 0 2 2 2 2 2 4. We have 1 2 3 4 5 6 7 7 data, n equals to 7. Mean, let's find the mean. X bar equals to you add these numbers and divide by 7. 4 5 6 7 8 9 10 11 12 13 14. 14 divides 7 is 2. So mean is 2. See, we got the same range and same mean. Okay, so we have the same range, 4 minus 0 4, and then the mean is same, but we get different standard deviation. Okay, let's see. Now the standard deviation we subtract. To get the standard deviation, we subtract 0 minus 2, 2 minus 2. We do this way: 0 minus 2 square plus 2 minus 2 square plus another 2 minus 2 square plus another 2 minus 2 square plus how many 2? 1 2 3 4 5 2. 1 2 3. Okay, so 2 minus 2 square plus 2 minus 2 square plus 4 minus 2 square, and then divide by 6, and then find square root. Okay, and what you get, okay, so 0 minus 2 is 2, negative 2, negative 2 square is positive 4, plus 0, because 2 minus 2 is 0, 0 square is 0, plus 0 plus 0 plus 0 plus 0, right? 1 2 3 4 5 zeros, and then plus 4 minus 2 is 2, 2 square is 4, divided by 6 square root, and then I have square root of 8 divides 6, and then square root of 8 divides 6 is, let's do it by calculator, 8 divided 6 equals to 1.33, and square root of that, square root of 1.33333 is 1.154. 1.154. This is the standard deviation for this data. Okay, so please look at these carefully. I didn't have much space, so I had to do it like this, right? So I hope that you follow these steps. So I'm doing these steps to find standard deviation for these numbers, to find these data. Okay, so this is the process to find standard deviation, to find the sample standard deviation. I will put another video maybe after a few days explaining on how we can get the standard deviation by using graphing calculator. So if you have a graphing calculator, you can use graphing calculator, like we use this graphing calculator, TI-84 plus. By using this graphing calculator, we can find standard deviation which has less steps than these. So I will put another video after a few days. Okay, but that is something like we can do by using graphing calculator. But the method to find standard deviation, the original method to find standard deviation is this. Okay, now we have one more question. This is the data, and we find the sample standard deviation and round it to the nearest 100. So we find the mean x bar, and here The mean is, let's say I have to do by calculator. I add the number and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 70, let me do it like this. Okay. I'm gonna find the mean now. Okay, so I add these numbers and divide by 10. 70 plus 72 plus 71 plus 70 plus 69 plus 73, 69, 68, 70, 71. 70.703 divided by 10 is 70.3. 70.3. Okay, so let me check this again. If I miss any, 70, 72, 71, 71, 70 plus 72 plus 71, I'm just double checking. 70 plus 69, 73, 69, 68, 70, 71. Yes, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yes, so this is the mean, 70.3. So this was right. Okay, now the next step is we do 70 minus 70.3 square plus 72 minus 70.3 square plus 71 minus 70.3 square plus, so we got this. Now 70 minus 70.3 square plus 69 minus 70.3 square plus 73 minus 70.3 square plus 69 minus 70.3 square plus 68 minus 70.3 square plus 70 minus 70.3 square plus 71 minus 70.3 square. Okay, and then you divide by 9 because there are 10 numbers, so 10 minus 1 is 9 because this is sample standard deviation, and then you find the square root. Okay, so when you do this, you get, it takes time to calculate these, but when you calculate this, you will get the final answer. You will get 1.494. Okay, you will get this answer. So be careful when you simplify, you will get this answer. So this is the standard deviation of this data. Okay, so it was like standard deviation has many steps, like it has 6 steps to follow, but you do very carefully. The data will be given, you find the mean and then subtract the mean, like you subtract the mean and square and then plus, and then subtract the mean square and plus, subtract the mean and square. So you do this, and then you divide by the total number of item minus 1. So if there are 10 numbers, subtract 1 and we get 9. So divide by 9. And then you find the square root of everything. And then you do careful calculation and you get the standard deviation. Okay, so this was in this lecture. So we did 5-number summary, box plot, and variance and standard deviation. And always the variance is the square of standard deviation, and standard deviation is the square root of variance. Okay, so that is the that is another thing that we should know. We always have that relation. Let me write here. Standard deviation is square root of variance. Okay, standard deviation is square root of variance, and variance so you have n equals to square of standard deviation. These two things we should know. Okay, so I will see you in next video, and within few days I will post the method to find standard deviation by using graphing calculator. But without using graphing calculator, we can find standard deviation by following these steps. And in the next lecture, we start probability now, and we will do probability. So this was all statistics part, and now we do probability from our next video. Okay, I'll see you there. Thank you.